Hello student, today we are going to discuss about how we find the particular integral of a difference equation, means a linear difference equation with constant coefficient. So general form of a linear difference equation with constant coefficient is a f of e yx equal phi x. So there are different form of a phi x. Here first we consider phi x equal e to power x. Then what is the particular integral? Where a is a what? Where a is a constant. Where a is a constant. A is constant. Is constant. So, what is the particular integral of this one? If we write a particular form of a particular integral, if phi x equal ax, then yx equal phi x. Phi x means phi x upon f of e. F of e, and if phi x is a to power x, a to power x, f of e, then this one equal, then particular integral equal a to power x, upon f of a, provided if f of a does not equal to 0. If f of a does not equal to 0, this one is a type 1. Means ax upon f of e be any form of a particular integral, then value of this particular integral is a to power x upon f of a, means in place of e just we write a. Now how we say that this one a to power x means a to power x, this one equal to a to power x f of a. So now if we try to prove this one, how we say that a to power x upon f of e equal a to power x f of a. So if we try to prove this one, proof of this one, as we know that f of e is a function of a e. Function of a e means this one is a polynomial of a degree n. So if we try to write, here if we write f of e into a to power x, then we know that what is the value of f of e? Value for f of e is we write here general form of a linear difference equation. From the general form of a linear difference equation with constant coefficient, this become a0 e to power n plus a1 e to power n minus 1 up to last one is an. Here ax. So if we operate a to power x over the shift operator, here e is the what? E is the shift operator. F of e is a polynomial of a degree, and here we write a general polynomial of a degree n. A0 like f of x equal a0 x to power n plus a1 x to power n minus 1 up to an. In a similar manner, here variable is e. So this one is a polynomial of a degree n, and general polynomial of a degree n is a0 into e to power n plus a1 e to power n minus 1 up to an. And if we operate the ax over ax, so here a0 e to power n means e to power n, and if we operate here a to power x means if we open the bracket here, we operate ax over this uh, inside this function over the shift operator. Ax plus a1 e to power n minus 1 e to power x, and similarly last one is a an a to power x. So if we operate the shift operator over a to power x, then nth order shift operator of a to power x become what? This become a0 a to power x plus n. This one a to power x shifted n time in the sequence of ax plus 1, ax plus 2 up to ax plus n. Similarly, if we operate the n minus 1th order shift operator, then this become a1 ax plus n minus 1, and similarly last one is a an a to power x. So if we closely observe this one, means if we take a to power x outside here, a to power x outside, then this become a0 a0 a to power n plus a1 a to power n minus 1 up to an, and outside the braces what become outside a to power x. So if we closely observe the function of this one, function of and this one, then this can be written as a function of a, because if we replace e by the a, then here we find a0 a to power n. If we write here equation number 1 0 1, then if we put in place of e equal a, then we find a0 a to power n plus a1 a to power n minus 1 up to an. So we may write this one equal f of a into a to power x, f of a into a to power x. Now what we get? We get here, if we write this one equation number 2 here, or not equation number 2, if here write f of e into a to power x equal f of a into a to power x. So in the next page, if we write the simplified form of above expression, then simplified form of above expression is a f of e a to power x equal f of a into a to power x. So now we operate 1 upon f of e both side, 1 upon f of e both side, then we get what? 1 upon f of e, this one is a small f of e into f of e a to power x equal 1 upon f of a into a to power x. So if we operate a 1 upon f of e over f of e, then this become what? A to power x equal f of a with the constant, so this become outside, so f of a into a to power x upon f of e. So if we simplify this one, then this become a to power x upon f of a. If f of a was on a left hand side, then a to power x upon f of a equal a to power x upon f of a. This one is a required result. So if we write here, you know, left hand side equal right hand side and right hand side equal left hand side, then this become a to power x f of e equal a to power x f of a. So this one is a required result. This one is a required result. So if particular integral of the type what of the type in particular integral of the type e to power x upon f of e, then this one equal to a to power x upon f of a, provided f of a does not equal to 0. F of a does not equal to 0. So this one is the case 1. Now suppose case second part of our case 1, as we say that if f of a does not equal to 0, but if f of a equal to 0, then what will happen? If f of a equal to 0, then what is the particular integral? So you cannot write a to power x upon f of a, because f of a equal to 0, then that value of the value of that particular integral becomes undefined. So in this case, particular integral, we write if f of a equal to 0, then particular integral particular particular integral particular integral then particular integral pi particular integral, if we write not here pi if we write here pi equal what? A to power x upon f of e equal what? This one equal 1 upon psi a a to power x f of e. If f of a equal to 0 means then f of e have a one factor, a is a one factor of f of e, then this become what? This become a to power x upon f of e can be written as e minus a psi of e Then in this case, what is the value of a particular integral? In this case, the value of a particular integral become 1 upon psi a 1 upon psi a into x into a to power x minus 1. So we try to prove this one. How we prove this one? So as we know that as we say that f of a equal to 0, if f of a equal to 0, then obviously e minus a is one of the factor of f of e. So we may write here uh, e to power x means a particular integral equal a to power x upon f of e. Here we assume that initially we assume that e minus a be a factor of order 1, means there is a one root exist at a one point, means in a f of e. So particular integral a to power x upon f of e, if f of a equal to 0, then e minus a is one of the factors. So this may be written as a to power x upon e minus a and one another function psi e. Now here we assume that let a to power x upon e minus a equal ux, means one another function of x ux. So if we simplify this one, so this can be written as a to power x equal e minus 1 ux. So if we operate the shift operator over ex, then what is the result? The result become a to power x equal e of a ux minus ux. So if we operate the ux over a shift operator, then this become ux plus 1, ux plus 1, ux plus 1, and here this one is a sorry, not a here, mistaken, we written this one is a. So this one is a ux plus 1 minus a ux equal what? Ax, a to power x. So if we multiply on both side by the a to power minus x plus 1, we multiply both side by, if we write here in the next page, if we write in the next page, then what is the result? Means what is the expression? Expression is ux plus 1 minus aux equal a to power x. So multiplying a to power minus x plus 1 on both side, then what is the result? This become a to power minus x plus 1 ux plus 1 minus a to power minus x plus 1 into a ux equal a to power minus x plus 1 into a to power x. So if we simplify, then we see that if we simplify this expression, means this expression, if we underline this expression, if we simplify this expression, then what is the result? Result become a to power minus x plus 1 u x plus 1 minus a to power minus x ux equal a to power minus 1, a to power minus 1. So if we closely observe this expression, this can be written as what? The left hand side can be written as del of a to power minus x ux, means the forward difference of this function a to power minus x ux equal a to power minus n. How we write this one? Means using the definition of a what? Using the definition of a forward difference operator. According to the definition of a forward difference operator, del of yx equal what? Yx plus h minus yx. If h equal 1, if h equal 1, then del yx equal yx plus 1 minus yx. So here we assume that yx is a function of what? Yx equal a to power minus x ux, then yx plus 1 equal what? Yx plus 1 means just we replace x by the x plus 1, then this become a to power minus of x plus 1 into u of x plus 1. So using the definition of a forward difference operator means by putting the value of a yx plus 1 and yx in this expression, then del yx become del yx means del a to power minus x ux equal this one uh, a to power minus x plus 1 ux plus 1 minus a to power minus x ux. So using this result means by the definition of a forward difference operator, we may write del a to power minus x ux equal a to power minus 1. So if we operate the forward difference operator, so forward difference operator, if we operate the forward difference operator means on the right hand side means if we operate 1 upon operate 1 upon delta on both side then this become del 1 upon del e to power minus x ux equal 1 upon del e to power minus 1. So what is the value of left hand side? A to power minus x ux. What is the value of right hand side? 1 upon del means inverse of a forward difference operator may be treated as a integration if we write the polynomial in terms of factorial notation. Later on we discuss about a factorial notation, but here this one is already in a factorial notation, so 1 upon delta can be treated as a integration. So what is the value of a 1 upon delta means one time integral value. If a independent variable is x, here independent variable is x, then this become what? A inverse x, the value of integration. So if we simplify this one, then what is the value of a ux? Ux become here the value of a ux become ux equal e to power minus x ux a inverse x, then ux equal x into a to power x minus 1. So this one is a value of a ux. So this one is a value of a ux. Just put the value of this ux here. Means here we put the value of a ux. This one we put the value of a ux here. This may be written as a, means you may write this one a to power x upon psi a into e minus a, and now put the value of this one ux. This one is a what? Ux. So you may write this one equal ux upon j a. So if this one is equation number what? This one is equation number 1. Equation number 1. Equation number 1. So just put the value of ux. Here we put the value of ux. Ux equal what? Ux equal, ux become what? Ux become x into a to power x minus 1. Now put the value of ux. Putting the value of ux. Putting the value of ux in particular integral 0 1. What is the particular integral? Particular integral equal e to power x upon f of e equal e to power x. E minus a is the one factor, j e. So this may be written as e to power x j a into e minus a. So here a to power 1 upon means ux upon j a. So just put the value of ux here, then pi become what? Particular integral become 1 upon j a into x into a to power x minus 1. So this one is a particular integral of type what? If ax upon, particular integral is a ax upon f of e equal a to power x upon j e minus a equal 1 upon j a into x into a to power x minus 1. This one is a value of a particular integral. This one is a value of a particular integral provided f of a equal 0. F of a equal 0. If f of a equal 0. If f of a equal 0. F of a equal 0. So if we generalize this one, means f of a equal to 0 and e minus a is a factor of order r, means if we generalize this one, general form of this case, general form of this case. So general form for this case is what I am saying. I am saying if f of a equal to 0, then E minus a is not a simple factor. E minus a is a factor of order r. So particular integral can be written as particular integral equal e to power x upon f of e if f of a equal to 0. If f of a equal to 0, then e to power x upon means e minus a to power r. E minus a is a factor of order r. E minus a to power r into xi e. Then in this case, what is the value of a particular integral? The value of a particular integral become x. This one is a factorial notation, xr upon factorial r into e to power x minus r into 1 upon xi a into 1 upon xi a 1 upon xi a. So what is the meaning of factorial notation? Factorial notation, here we write xr is a factorial notation. So what is the meaning of a factorial notation? X1 equal 1 equal x. X2 means, here if we write x2, this become x into x minus 1. Similarly, x3 in a factorial notation, x3 equal what? X minus 1, x minus 2. And similarly, xr equal x factorial notation r equal x minus 1 up to x minus r minus 1. So this one is the meaning of this notation, x factorial notation r. Now, if we summarize the first type of a particular integral, so summary of a first type of a particular integral, so summary of a type 1 integral, type 1 particular integral, type 1 integral of f of e yx equal e to power x, where a is a constant, a is constant. So summary of this type of integral means this type of a particular integral, there are two cases. Case 1, what will happen in a case 1 means a particular integral equal means a particular integral equal a to power x upon f of e. Then this one equal e to power x upon f of a, provided where f of a does not equal to 0. Case second, if we talk about a case second, particular integral means if f of a equal to 0, if f of a equal to 0. So if we write a general case means e minus a is a factor of order r, then particular integral, here if we write a particular integral equal a to power x upon f of e equal a to power x upon e minus a to power r into xi e. The value of this particular integral, as we prove in a little bit, we prove earlier, means what is the value of this particular integral? The value of this particular integral is a to power x, here 1 upon xi a, 1 upon xi a into 1 upon xi a into x to power, in a factorial notation, this one is a xr upon factorial r into a to power x minus r. A particular case of this one, a special case, a particular case, if r equal 1, then pi, particular integral, become a to power x f of e equal a to power x upon e minus a s j of e equal 1 upon xi a into x to power 1 means x. So this become x into a to power x minus 1 divided by factorial 1. So this one is a what? This one is a particular case. So this one is a type 1. So this one is a summary of a type 1. Now we solve one numerical example based on this type of a integral, or this type of a differential equation, this type of a particular integral. So now we try to solve two example. Here we take a two example. First one for the case 1 and second one for the case 2. So here first we take example 1 for the case 1. So suppose here we take a example, very simple example. Suppose here we take a yx plus 2, solve yx plus 2 minus 4yx plus 1 plus 3yx equal to the power x. So now we find the solution of this one. So first we write this difference equation in a standard form, means in form of a shift operator. So yx plus 2, we write this difference equation in terms of a shift operator, then this can be written as yx plus 2 minus 4yx plus 1 plus 3yx equal to the power x. Now this one is a what? This one is a e square yx, 4 times of e of yx e of yx plus 3yx equal what? To the power x. So if we simplify more this expression, then this become e square minus 4e plus 3 yx equal to the power x. So if we compare with the standard form of a linear difference equation with constant coefficient, then what is the standard form of a linear difference equation with constant coefficient? F of e yx equal phi x. So if we write if we compare this expression, means expression 0 1 with the second one, then what is the value of a phi x? The value of a phi x equal to the power x, means in the form of a to power x. So how we find the particular integral? So particular integral become phi x, means a to the power x on f of e, where f of e equal, this will become to the power x upon f of e is a e square minus 4e plus 3. So as we know that, just we put the value of a in f of e. In place of e, we write a. So what is the a here? If we compare with the standard, means this form of a particular integral here, if we closely observe, the particular integral of a to power x upon f of e equal a to power x upon f of e, means we replace e by the a. So here, what is the value of a? The value of a is a 2. So just we replace e by the a. So what is the value? The value become to the power x 2 square minus 4 into 2 plus 3. So this become, we write here, to the power x divided by 4 minus 8 plus 3. 4 minus 8 plus 3. So what is the value for this one? The value for this one is a minus 1. So this become minus to the power x. This one is a value of a particular integral. But what is the solution? As we know that solution of any difference equation, if that one is in form of a linear difference equation with constant coefficient, means if a given difference equation is a linear difference equation with constant coefficient, then solution is a yx equal complementary function plus particular integral. How we find the complementary function? So be able to find out the value of a particular integral. The value of a particular integral become minus 2 the power x. Now what is the complementary function? Complementary function can be obtained by putting f of e equal 0. So if we put f of e equal to 0 here, what is the f of e? F of e is a e square minus 4e plus 3. E square minus 4e plus 3. So e square minus 4e plus 3, this one equal to 0. So if we simplify, then what is the value of what is the factor of this one? Factor of this one is 1 and 3, means e minus 1 into e minus 3 equal to 0. So what is the value of e? E become 1 and 3. So if e become 1 and 3, means the root are real and distinct. So what is the complementary function? complementary function become C1 1 to power x plus C2 3 to power x. So what is the solution? If we write the solution here, then solution become yx equal complementary function means a C1 1 to power x plus C2 3 to power x. So this one is a complementary function plus particular integral is a this one is a minus 2 the power x here minus 2 the power x minus 2 the power x. So in a simplified form, not a minus 2 the power x, it be right here in this form means a minus 2 the power x minus 2 the power x. So this one is a what? This one is a solution of a given difference equation. This one is a solution of a given difference equation. Now we take one another example where f of a equal 0. So if we closely observe in this example, factor is a what? E minus 1 and e minus 3. E minus 1 and e minus 3. So if in a right hand side, in place of a 2 the power x, if there is a 3 to power x, then f of a become 0. So for sake of simplicity, we take again this example, and on a right hand side, in place of a 2 the power x, we write a 3 to power x. Then what is the solution of that difference equation? Means if we take another example, example number 2, and in this example, left hand side remains same as in example 1, means yx plus 2 minus 4yx plus 1 plus 3yx equal 3 to power x. So what is the solution of this one? If we try to find out the solution of this difference equation, so again, what is the solution? Yx equal complementary function plus particular integral. As in a previous example, already we find the value of a complementary function. So what is the complementary function? To find out a complementary function, first you write the given difference equation in standard form of a linear difference equation with constant coefficient. So if we write the given equation means equation 1 in a standard form means a linear difference equation with constant coefficient in form of a f of e yx equal phi x, then this become yx plus 2 means this can be written as e square yx means this can be written as e square yx minus 4 e of yx plus 3 yx equal 3 to power x. So this become e square minus 4e plus 3 yx equal 3 to power x. So if we compare with the standard result, so what is the value of f of e? F of e equal e square minus 4e plus 3, and what is the phi x? Phi x equal 3 to power x, and if we compare with the standard form means a to power x, then what is the value of a? This implies that a equal what? A equal 3. So what is the value of f of a? If we f of a means f of 3 equal to what? 3 square minus 4 into 3 plus 3. So what will happen here? 3 3s are 9. 9 plus 3, this one is equal what? This one become 9 plus 3, 12, and 12 minus 12, this become 0. So f of 3 becomes 0. So f of a equal to what? F of a equal to 0. So if f of a equal to 0, then what will happen? Then particular integral become here. If we write a particular integral, first we write a particular integral because we already uh, find the value of a complementary function. So in this case, what is the particular integral? Form of a particular integral, if we write from here, particular integral, then particular integral become what? Particular integral become 3 to power x upon e square, means f of e, and this become 3 to power x f of e with the e square minus 4e plus 3, and this become 3 to power x, because f of a equal to 0, so first we find the factor of a polynomial, so this become e minus 3 and e minus 1, e minus 1. So if we write in a standard form, so this become 3 to power x e minus 3, e minus 3, and this becomes xi e. So what is the solution? As earlier we discussed about this one, what is the solution? If this one is in this form, a to power x e minus a xi a, then solution is a 1 upon xi a into x into a to power x minus a upon factorial 1. So in this case, what is the solution? Solution become 3 to power x, not 3 to power x, sorry. So 1 upon xi a means 1 upon xi3 into x, means here we write x into a to power x minus 1 into 3 to power x minus 1. So if we simplify this one, in place of a e, we put a 3 here, means here this one is a what? This one is a xi a. This one is a xi e. So if we put e equal 3, then xi 3 become what? Xi 3 become 3 minus 1, means 1 upon 2. 1 upon 2 into x into 3 to power x minus 1. This one is a particular integral. Now, what is the complementary function? So if we try to write a complementary function of this one, so how we find a complementary function? Just we put f of e equal to 0. This means this implies that f of e with the e square minus 4e plus 3 equal to 0, and factor of this one is e minus 1 and e minus 3, so e equal what? 1 and 3. So what is the complementary function? Complementary function become, as in a previous example already we write the complementary function of this difference equation. The complementary function of this one is a c1 1 to power x plus c2 3 to power x, and earlier we find a particular integral. Particular integral in this case become what? Pi become 1 upon 2 x into 3 to power x minus 1. So what is the solution? Solution is, as we know, that solution of any difference equation is a complementary function plus particular integral. So here just we put the value of a complementary function and particular integral, then we able to find out the desired solution. So this becomes C1 1 to power x plus C2 3 to power x 3 to power x 3 to power x plus particular integral is a 1 upon 2 x into 3 to power x minus 1. So just here we underline, we enclosed this one. So this one is a what? This one is a solution of a given difference equation. This one is a solution of a given difference equation. So this one is a type 1. Later on we discuss about some other types of a particular integral, and later on we are not going to prove the means how we get the form of a particular integral. Just we write a standard form of a particular integral and try to solve some numerical example. Thank you. Thank you for watching the lecture. Thank you.